through, unquestionably, the most exciting time in the computer industry that all of us have ever witnessed. What we thought was going to be science fiction for years to come is becoming reality as we speak. Our work at Nvidia is dedicated towards a computing model focused on visual and AI computing. It's built on top of the GPU that we pioneered. This computing model is able to solve problems that normal computing isn't able to solve. And we dedicate ourselves to tackling the most challenging computing problems in the world. There are 4 areas that we focus on. Surprisingly for many, over the years, we've dedicated ourselves to video games. Not to mention the fact that it's incredibly fun, it's incredibly beautiful, and we love it. Video games is also the highest volume, most computationally intensive application the world has ever known. It is about achieving virtual reality. And now all of a sudden, all the technologies are coming together for us to finally achieve virtual reality, augmented reality, mixed reality, and bring together the experience of the holodeck for real for the first time. Computer graphics technology, computer vision technology, and artificial intelligence will come together to realize this exciting new computing platform that we call VR, AR, or mixed reality. Our technology is also used in the cloud. AI supercomputers are being built all over the world today, so that all of you, when you're talking to the internet, when you're making queries, those searches all pass through artificial intelligence. So that the query that you make, the assistance you seek for, is much more helpful to you. And then lastly, some of the most exciting things we're working on today, the most impactful work that we're doing for the society, for the industry, self-driving cars and autonomous vehicles. These 4 areas we've been endeavoring for some time. And then all of a sudden, in the last several years, an enormous breakthrough happened. Researchers all around the world working in a new field, a new technique of machine learning called deep learning, met the GPU and the big bang of artificial intelligence happened. This technique allows software to write software, allows computers to learn from experience and data, and allows the computer to recognize complex patterns that are easy for you and I, but incredibly hard for computers. And it does so by hierarchically building up feature representations to represent very complex information, complex patterns, but building it up from hierarchies of simpler patterns. The ability to recognize a face, for example, with its infinite variability, built on layers and layers and layers of artificial networks. The lowest layer could just be edges made up of pixels. The layer above that could be contours, shapes, textures, motifs. The layer above that could be parts of the human face. And then eventually, it's able to understand the representation of a face. And to understand the representation of a face in its incredible variability. It could be, you could be wearing your hair a little bit differently. You could be wearing a hat. You could be looking away partly. And somehow, we human can recognize that person. Finally, for the very first time, using this technique called deep learning, we're able to do the same with computers. This ability to perceive the world is just an enormous breakthrough, and I'm going to show you why. Why this foundational technology, foundational capability was so important. It just had one incredible challenge, one incredible handicap, and that is the amount of computation necessary. The amount of data processing necessary is absolutely enormous. And then one day, the AI researchers met the GPU that we invented, and the big bang of modern AI happened. The achievements have been fast and furious. Some of the things that we've been able to accomplish in just the last several years, absolutely mind-blowing. You have all heard about the AlphaGo achievement. Demis Hassabis and his DeepMind team was able to teach a computer how to play Go, the most complex game we know how. More variability than all the atoms in the universe. More moves. And yet, this computer was able to learn Go from the world's masters and then play the master of our modern era, Nvidia. Network has been able to play Doom, which is a game of maze. Maze finding, resource management, while you're staying away from monsters. A network is able to learn how to play Go. A network has been able to learn the style of artists, Van Gogh, Monet, Picasso, and apply that style to photographs. A network has been able to synthesize our voice. Instead of our voices stitched together from a whole bunch of little tiny chunks, this network is able to learn the tonation of our voice, and from the words that we feed it, synthesize how we would speak. A network was able to learn to recognize an image and understand its context and caption that image. A network was able to turn images that it sees in computer cameras and translate it directly through repeated trial and error, called reinforcement learning, to eventually adjust its motors and learn motor skills. A network was able to learn how to walk by itself. Just by teaching it the kinematics of a robot that was actually sitting on the ground, after repeated trying, the robot was able to stand up and walk. And in fact, we've been able to teach a car how to drive. Driving is a skill. It's not mathematics. Kids can learn how to drive, adults drive, and yet we do no computation whatsoever. We do no Newtonian physics whatsoever in our head. We just drive. We've been able to teach a car how to drive. The achievements that you see in front of you is impossible until just recently. It was just impossible until recently. And all of a sudden, because we're now able to understand the complex nature of the world, to perceive the world through vision, through audio technology, through natural language, we're now able to apply artificial intelligence to solve problems that we had never conceived of in the past. The enabling technology behind all of these great achievements is GPU computing. And that GPU had the benefit over 23 years. That GPU had the benefit over 23 years to be fueled by the single largest simulation industry in the world. The single largest entertainment industry in the world, video games. To many, it's just for fun. To us, it's incredibly fun. Not to mention, it propels the science of our company. PC gaming is thriving and vibrant. It has doubled in the last 5 years to $31 billion. It is the single largest game platform today. And GeForce is PC gaming. GeForce is also thriving and vibrant. In the last 5 years, it has doubled in revenues. There are 200 million GeForce gamers around the world. The dynamics that are driving this business is multi-dimensional. Of course, it is a global industry. And before anyone has a game console, or even ever gets a game console, everyone has a PC. And almost every single human today is a gamer. There are several 100 million core gamers in the world today. I expect there to be several billion gamers someday. Our technology is also fueled, and this market is also fueled by the amazing production value of the video games that continues to come out. In the last 5 years, gaming technology has increased in performance by a factor of 10. And now 4K, HDR, and virtual reality is coming. Gaming is no longer just about games. Gaming is now the world's largest sporting event. The world's largest sporting event. In fact, it is very, very likely that esports will someday be larger than all of the other sports events combined. Esports, 100 million video gamers. When you watch them play games, it's a game of intelligence, it's a game of tactics and strategy, it's a game of teamwork, and it's also a game of incredible hand-eye coordination. The training is intense, the number of people who enjoy it, 325 million spectators for esports, are now part of this very young sport. Not only is gaming a game, a sport, it is also now social. There are more people than ever that watch video games, watch other people play video games. 600 million video gamer viewers. 2 trillion minutes have been watched in just the last several years. This is now a $5 billion advertising industry, one of the fastest growing areas of internet video that we know. PC gaming is thriving, GeForce is thriving, and all of that is propelling the incredible R&D budget that we're able to support. Today we're announcing, the first announcement is to connect GeForce, the #1 gaming platform in the world, to the #1 social platform in the world. And I'm going to show you what that means in just a second. But basically, GeForce has a software platform above it that's connected to tens of millions of gamers. And this software platform today is able to allow you to capture pictures, capture a video, capture a VR picture, so your video game can be shared with other people who want to spectate and watch it in VR, and you can also live broadcast. Our platform, the GeForce platform, with GeForce Experience, is connected to all of these social networks. And today we're going to connect it directly with just 2 clicks to Facebook. There are already millions of people who are watching us stream this on Facebook, and they've been told that there's something really, really amazing that's going to be revealed. And to help us celebrate this incredible connection, we're going to share with the world never before seen footage of one of the most anticipated video games of 2017, Mass Effect Andromeda. Let's welcome Aaron Flynn to the stage. Tell us a little something about Mass Effect, but before you tell everybody, you guys have been working on this for quite a few years. I mean, this is the 4th chapter of this incredible franchise, and it is just going to be a doozy of a new chapter. Tell us.
Thank you. Yeah, absolutely. We've been on this game for almost 5 years now, since it started as an idea. We wrapped up the Mass Effect trilogy and knew we wanted to tell a new story with new characters and new places to go and explore. And so we reached out and decided we need new technology to do that. That's how we turned to Frostbite. We started working with the Frostbite team and really investing in that and building on that. And that's allowed us to do all sorts of really cool things. Larger environments than ever before, more dynamic, more detailed characters than ever before to tell stories with, and even better gameplay now with verticality and destruction.
The thing that's really amazing about Mass Effect is it's an RPG, but the story is really, really deep. I mean, these are explorers that are traveling to the Andromeda Galaxy.
Absolutely, yeah.
And they're able to do so, of course, at faster than light, speed of light.
Absolutely.
Because they're able to use this incredible element that they found called Element 0 on Mars, and as a result, reduce their mass to 0.
That's excellent, Jensen.
Isn't that
That's
right?
amazing. Wow. That's great.
And you and I both know that unless your mass is 0, you have no shot of traveling at the speed of light.
I've heard that, yes.
And therefore, Mass Effect. Ladies and gentlemen,
Brilliant.
Mass Effect. And the thing that's really amazing, and as we're talking about this, and I just want to take just a couple more seconds to build a suspense for all of the gamers that are on the web. There are millions of people who are watching, and they're going to tear down everything that you showed them in a moment. I mean, all the skill trees that are going to be revealed for the very first time, the weapons that are going to be revealed for the first time, the aliens that you might show for the very first time, right? The battle tech that you might show for the very first time. I mean, every one of those frames are going to be stop framed, and they will be dissected endlessly until this game launches.
Endlessly, yeah.
Would you say?
Oh, absolutely, yeah. And I expect no less of our fans, to be honest. It'd be great to have them do it.
Okay, so what we're going to show you here is this. These are real game footage.
Absolutely, yep.
Running on a GeForce GTX 1080.
Absolutely.
And it's captured, and it uses some pretty amazing new technology that you guys are going to show, and it's never before seen. Ladies and gentlemen, Mass Effect Andromeda, Aaron Flynn's Studio BioWare. March 21st?
Yeah, March 21st. Somebody put out to me that was 3, 2, 1, so I guess blast off then.
March 21st, that's amazing. Now, of course, I could sit here and look at that forever. I just love explosions and fire and smoke and all particle effects. And of course, everybody sees beautiful things, and all we see is computer graphics and the mathematics behind it. And so the things that how about highlighting a couple of things about the Mass Effect game, the game mechanics, or things that you might want to highlight?
Yeah, sure. So in that mission there, we were helping one of our squad mates named Peavy go and earn some loyalty from her. So that was part of her loyalty mission. That's a whole new planet there you get to go to and explore. You're learning about her background, learning about the background of the Remnant, who are the robots there who you were fighting, and you're seeing things like our dynamic profile system, which lets you change your character class dynamically in real time, something new to Mass Effect. You're seeing all sorts of verticality in there, you're seeing the destruction, you're seeing all that good stuff now available in the drop.
That's unbelievable. Everybody, Aaron Flynn, thank you.
Thanks, man.
Mass Effect Andromeda launched here, direct to gamers all over the world on Facebook Live, streamed directly from CES. Well, you could see that video game is just unbelievable. And yet, if you think about the number of PC gamers in the world who would like to get into PC gaming, or there are people that they have a thin and light notebook, but they would like to enjoy some PC gaming every now and then, and just haven't dedicated themselves to build a new GeForce PC. The number of those PC users is shockingly high. There are 2 billion PC users in the world. We estimate some billion users with integrated graphics or Macs or older PCs or thin and light notebooks that would love to be able to enjoy games but simply don't have the capability to do so. And in fact, there's really no real way of installing a new GeForce graphics card into those computers. And maybe they're rather intimidated by opening up their computer in the first place and building something new. And we thought that wouldn't it be amazing if we were to put a GeForce gaming PC, a state-of-the-art GeForce gaming PC powered by Pascal, in the cloud like AWS. Build a supercomputer. Like AWS does for enterprises, we would do this for consumers. And as a result, these supercomputers in the cloud could be shared by millions of gamers around the world. They could try video games for the very first time. If they don't play frequently, they could launch a game whenever they want, wherever they want. And if they could just enjoy state-of-the-art video games like this with just a click of a button, wouldn't that be utterly amazing? So after many years of endeavor, this is just one of those incredibly hard problems. And it's incredibly hard because the computational capability necessary for video games is so high, and the interactivity requirement is so high that any little bit of latency would ruin the experience. And so after just so much refinement, so much re-architecture, so much engineering, the team has finally done it. Ladies and gentlemen, we're announcing today GeForce Now for PCs. It's put... GeForce Now. It turns any of your PCs with the download of a little tiny client with a click of a button, into essentially your most powerful gaming PC. And it's all in the cloud, just one click away. Why don't we take a look at it? Okay, so what you're looking at here, 2 computers in the back. One is based on PC, one is Mac. Your usual desktop that you recognize. The thing that you instantly recognize on the PC side is all of the major stores and hubs are now available, and they work perfectly. Steam, with 150 million users, works perfectly. Origin from Electronic Arts works perfectly. Uplay from Ubisoft works perfectly. Multiplayer works perfectly. All of your stored states, your checkpoints, all of your friends, all work perfectly. Every single game works exactly as it should. All of the software has been updated. Dave, are you in the back?
Yeah, hi Jensen.
Hey Dave, Happy New Year first of all.
Hey, Happy New Year to you.
Why don't we do this? Why don't we launch Steam? Steam is the single most popular video PC gaming store in the world. And here David's launching Steam on GeForce Now.
We're just going to launch this on the
15
PC.
seconds or so. Okay, there you are. And there you are, just a few seconds, you're into Steam, and all of the games that you've purchased or all of the games that you brought into Steam are all there. It also works on the Mac. So when we go over to the Mac, it's just one of the apps on Mac. Double click on that. There it is, Steam on Mac. And you can buy a game right there. You can buy a game right there. We won't do so right now, but we can buy a game. And usually when these video games are so large, they're so large because they have so much content, it takes hours and hours to download it.